Let's start with electricity. You probably think you already understand it. After all, you live inside it. At this exact moment, tiny charged particles are moving through the screen you're staring at. Electricity is lighting your room, keeping your food frozen, filling your battery bars. It's so common that it fades into the background. It feels obvious, familiar. So, you understand it, right? Alright then, explain it. What actually happens when you plug something into the wall? Where does that power truly come from? What is electricity, really, when you strip everything else away? Most people answer with labels. It's energy. It's electrons flowing. It's current in a wire. But those aren't explanations. They're just new names for the same mystery. Yes, electrons move, but why do they move? What force is pushing them? And how does that invisible push suddenly become light, heat, sound, or motion? Here's the uncomfortable part. The truth is stranger than you expect. Electricity isn't simple. It isn't tame. It's deeply, unsettlingly weird. And the way we usually teach it hides that fact completely. We smooth it out. We make it sound safe, predictable, boring. But once you actually look at what's happening, once you pull the curtain back, you realize we're not using some ordinary tool. We're manipulating something extraordinary. Something that quietly shatters your intuition about how reality is supposed to work. Let me show you what I mean. Try a small experiment. A simple one. Take a piece of plastic wrap. Tear off a strip. Now rub it hard between your hands. Fast, like you're trying to build heat. Then stop. Hold the plastic close to the back of your hand. Don't touch. Watch what happens. The tiny hairs on your arm begin to move. They lift. They lean. They stretch toward the plastic. You can feel it pulling on you, even though there's nothing connecting the two. Pause on that. All you did was rub a piece of plastic. That's it. No battery, no wire, no outlet, no hidden power source. Just friction. And somehow, that plastic can now reach across empty space and tug on your body. How? In everyday life, forces only seem to work through contact. You push a chair, you touch it. You pick up a book, you touch it. As far as your intuition is concerned, pushing and pulling require direct contact. Except here, they don't. Here's a piece of plastic that never touches your skin, yet it's pulling on your arm hairs through open air. Most people dismiss it instantly. Static electricity. You learned it in school. Middle school. Case closed. Not important. Just a trick. But that's the mistake. What you're watching is the same force that holds every atom in your body together. The force that makes chemistry possible. The force that allows your neurons to fire, your muscles to move, your eyes to respond to light. You're witnessing one of the 4 fundamental forces of the universe, openly demonstrating that it can act across distance. And we treat it like a party trick. This is the real problem. We've lived with electricity for so long that we've forgotten how completely unhinged it is. So let's slow down and unpack what actually just happened. When you rubbed that plastic, something subtle but profound happened. You peeled electrons off your skin and dumped them onto the plastic. Not many, just a few trillion extra electrons. That sounds small. It isn't. Because here's the part that bends your mind. Those extra electrons hate being near each other. Not metaphorically, physically. They repel one another with a force so extreme, it's almost impossible to grasp. But let's try. Imagine 2 electrons, sitting just 1 centimeter apart. The electromagnetic force pushing them away from each other is about 10 to the power of 42 times stronger than the gravitational force pulling them together. 10 to the 42. That's a 1 with 42 zeros after it. At that scale, gravity doesn't just lose, it's irrelevant. For electrons, gravity may as well not exist. Electromagnetism is everything. So this raises a terrifying question. If these forces are that absurdly powerful, why isn't everything flying apart? Why doesn't matter simply rip itself to shreds? The answer feels almost like a trick. Cancellation. To see why, you have to look closely at what an atom really is. At its core sit protons, carrying positive charge. Surrounding them are electrons, carrying negative charge. Plus and minus. Positive and negative. And these charges obey a brutally simple rule. Like charges repel, opposites attract. Here's the key. Those forces are perfectly matched. The strength of repulsion is exactly equal to the strength of attraction. So in ordinary matter, you end up with an incredibly tight weave of opposing charges. Protons and electrons packed together as closely as the laws of physics allow. Every positive charge is wrapped in negatives. Every negative charge is surrounded by positives. The forces don't disappear. They cancel. Enormous repulsion, neutralized by equally enormous attraction. The result looks calm, stable, solid. But beneath that calm is a storm of forces so powerful that even the tiniest imbalance becomes impossible to ignore. On the surface, everything looks neutral, balanced, calm, but the forces haven't gone anywhere. Those colossal electromagnetic forces are still there, still active, still pulling and pushing with unbelievable strength. They're just balanced so perfectly that the final result adds up to zero. And that's the key. When forces are this enormous, you don't need much to break the balance. Even the smallest imbalance becomes something you can feel. When you rub that plastic wrap, you didn't move many electrons. Maybe one extra electron out of a trillion. That's practically nothing. And yet, it was enough to make the hairs on your arm rise up. Because when the forces underneath reality are that powerful, even a microscopic excess produces a macroscopic effect. Once you understand this, your idea of matter starts to fall apart. Pick up a mug. Hold it in your hand. Ask yourself, what are you actually feeling? You think you're sensing the solid hardness of ceramic. You're not. What you're feeling is electromagnetic repulsion. The electrons in your hand are pushing violently against the electrons in the mug. They refuse to occupy the same space. They refuse to overlap. That's why your hand can't pass through the mug. Not because the mug is solid, but because the electromagnetic forces are overwhelming. In fact, your hand never truly touches the mug at all. There is always a tiny gap, an atomic scale distance, between the atoms in your skin and the atoms in the ceramic. No contact, just force. What you experience as touch is the electromagnetic field pushing back against you. And here's the idea that should completely rearrange how you see the world. Every force you have ever felt, every push, every press, every sensation of resistance is electromagnetic. Every push, every pull, every feeling of pressure, resistance, or touch, all of it comes from electromagnetic attraction and repulsion acting across space. You have never actually touched anything in your life. Not once. Whenever you think you're touching an object, what you're really experiencing is electrons in your body pushing back against electrons in that object through empty space. The same force you saw with the plastic wrap, just happening at distances so small that the forces become overwhelming. Touch is an illusion. Force is real. Now, let's move from your hand to a wire. Picture a copper wire running through your house. One end connects to an outlet. The other end connects to a lamp. You flip the switch. The light turns on instantly. So what just happened? The usual explanation says electricity behaves like water. Electrons enter the wire at one end, flow down its length, and pop out the other side. That story feels intuitive. And it's wrong. In reality, electrons inside a copper wire drift painfully slowly, about a millimeter per second. At that speed, a single electron would need close to half an hour to crawl across your house. Yet the lamp responds immediately. So if the electrons aren't racing down the wire, what's actually happening? Here's the crucial insight. The wire isn't empty. It's already packed with electrons. Copper is packed with free electrons, already there, already mobile, just waiting. When you flip the switch, you don't inject new electrons into the wire. You create a voltage difference, a pressure. That voltage pushes on the electrons near the switch. And because electrons repel each other across space, that push doesn't stay local. It instantly affects the next electron, which pushes the next, which pushes the next. The effect ripples through the entire wire. Think of a long line of people standing shoulder to shoulder. If you shove the first person, the last person reacts almost immediately, not because the first person ran down the line, but because the force traveled through the crowd. Electricity works the same way. The signal, the push, moves through the wire at nearly the speed of light. Not because electrons themselves are moving fast, but because electromagnetic forces transmit the pressure almost instantly across distance. That's why electricity is useful. You can apply a push here and get a response there, almost immediately, even across enormous distances. But this raises a deeper question. Where does that push actually originate? Follow the path backward. Your lamp connects to an outlet. The outlet connects to wires in your walls. Those wires lead outside into power lines. And those power lines stretch all the way to a power plant, maybe a few miles away, maybe 100. And inside that power plant, something enormous is moving. A turbine the size of a building, weighing tons, spinning thousands of times per minute. That spinning motion, happening far away, is what makes your lamp glow. How is that even possible? The link between that rotating turbine and the light in your room is magnetism. And here's the critical realization. Electricity and magnetism are not separate phenomena. They are not different forces. They are two faces of the same thing. A single, unified force. The electromagnetic force. When electric charges move, they create magnetic fields. And when magnetic fields change, they force electric charges to move. You can't separate the two. They're locked together. This is the heart of how a generator works. Take a coil of copper wire and spin it inside a magnetic field. As the wire moves, the magnetic field presses on the electrons inside the copper. The electrons resist at first, but the field doesn't let them stay still. You force them to move. That motion of electrons is electric current. That's the whole recipe. Motion, magnets, and copper. Nothing more. Now flip the process around. Send electric current through a copper wire sitting in a magnetic field. The moving electrons feel a force. That force pushes the wire itself. The wire moves. That's a motor. Same physics. Opposite direction. Generators convert motion into electricity. Motors convert electricity into motion. And this works for one reason only. Electricity and magnetism are two expressions of the same underlying force, which should sound impossible. You're saying that I can move metal in one location and metal in a completely different place responds, even though nothing connects them except a thin strand of copper? Yes. You're saying that spinning a magnet near copper creates a push that races through wires and makes other copper move? Yes. And this isn't rare. We do it constantly. Every motor, every generator, every power grid on Earth runs on this principle. Water falls on one side of a dam. Turbines begin to spin. Copper coils sweep through magnetic fields. Electrons are pushed into motion. That push races through hundreds of miles of wire at nearly the speed of light. It reaches your home, forces electrons through a motor, and your fan begins to spin. Water falling in one location makes a machine turn in another place, miles away, connected by nothing more than a thin strand of metal. That's absurd, and it's real. What's even stranger is that you don't even need permanent magnets. Take a simple coil of copper wire. Send electric current through it. The moving electrons generate a magnetic field. Now place that coil near another coil of copper. As the magnetic field changes, it pushes on the electrons in the second coil. Those electrons start moving too. Current flows, without any physical connection. That's a transformer. And that's how the power grid works. Just copper. Just motion. That's all it takes. Metal communicating with metal across empty space using electromagnetic fields. Now here's the idea that should completely rewire how you see reality. Earlier, I said that every force you feel is electromagnetic. Every push, every pull, every sensation of pressure or resistance. Think about what that actually means. The forces you experience every day, the so-called normal or mechanical forces, aren't fundamental at all. They're side effects. The electromagnetic force is the foundation. Everything else is built on top of it. When you push on a door, you're creating electromagnetic repulsion between electrons in your hand and electrons in the door. When you walk across the floor, electromagnetic forces between electrons in your feet and electrons in the ground are holding you up. When light enters your eyes, oscillating electromagnetic fields shake electrons inside your retina. That's vision. Chemistry works the same way. Interactions between electrons and atomic structures, all governed by electromagnetic forces. No exceptions. Heat is atoms vibrating, held together by electromagnetic forces. Biology is chemistry, and chemistry is electromagnetic interaction, which means something profound. Every sensation you've ever had, everything you've ever seen, felt, or experienced, is the result of electromagnetic forces interacting with your body. That's your entire interface with reality. And here's the deepest part of all. You can't explain the electromagnetic force using anything simpler. You can't say it's like a spring or like a rope, because springs and ropes themselves only exist due to electromagnetic forces. Any analogy you try to use already depends on the thing you're trying to explain. Electromagnetism is fundamental. It's one of the 4 basic forces of nature. A brute fact about how the universe works. You don't reduce it further. You accept it, and then everything else starts making sense. That acceptance is uncomfortable because electromagnetic forces act across distance. They don't require contact, and that clashes with your intuition. You evolve to understand pushes and pulls that involve touching. But contact, as it turns out, is an illusion. There is no true contact. Only electromagnetic forces acting across incredibly small gaps. To truly understand electricity, you have to rebuild your intuition from the ground up. You have to accept that the universe is made of fields filling all of space. That charged particles influence one another through those fields. That action at a distance isn't rare, it's normal. Now, with that understanding, revisit something familiar. You flip a light switch. Here's what actually happens. You complete a circuit. Electrons throughout the entire system begin drifting, slowly, about a millimeter per second. Far away, inside a power plant, a massive turbine spins. Magnets rotate past copper coils. The changing magnetic field pushes electrons into motion. Those electrons push on neighboring electrons. That push races through hundreds of miles of wire at nearly the speed of light. It reaches your home. Electrons are forced through a thin filament. The filament resists. It's hard for electrons to squeeze through. That resistance creates heat. The filament gets so hot it glows white. Electromagnetic waves burst outward. Some of those waves strike your eyes. The oscillating fields move electrons inside your retina. Those movements trigger chemical reactions. Those signals race through your neurons to your brain, and you perceive light. Every single step in that chain is electromagnetic. The turbine spinning? Electromagnetic forces. The signal traveling through the wires? Electromagnetic repulsion. The resistance in the filament? Electromagnetic interaction. The light itself? Electromagnetic waves. Your ability to see it? Electromagnetic motion inside your eyes. It's all the same force, wearing different masks. Pause for a moment and really think about that. 200 years ago, none of this existed. No electric light. No motors. No instant communication. Then we uncovered these forces. We learned how to control them. We built machines that could generate electricity, send it across continents, and turn it into useful work. And in doing so, we rewrote human civilization. Electricity gave us instant communication, telegraphs, telephones, radio, television, the internet, all powered by electromagnetic signals. It gave us artificial light and cities that never sleep. It gave us motors, machines that perform work without muscles, without animals, without exhaustion. It gave us computation, billions of microscopic switches orchestrating electromagnetic forces to process information. Every corner of modern life depends on electricity, and all of it rests on a single realization. There exists a fundamental force that acts across distance. Learn how to manipulate that force, and you can do things that would look like pure magic to someone living 2 centuries ago. So what is electricity really? Electricity isn't an object. It isn't a fluid. It isn't a substance flowing through wires. Electricity is the name we give to the act of harnessing the electromagnetic force to accomplish work. But at an even deeper level, electricity is something else entirely. It's evidence that the world is not what it appears to be. The world appears mechanical. Solid objects pressing against one another through direct contact. But that picture is a lie. What's really there is a universe made of fields and forces, acting across distance, particles pushing and pulling on each other through what looks like empty space. When you watch plastic attract tiny pieces of paper, you're witnessing the same fundamental force that allows atoms to bond and chemistry to exist at all. When you flip on a light, you're not just powering a bulb. You're commanding electromagnetic fields that stretch invisibly through space. And once you truly grasp that, once it clicks, everything shifts. You begin to see that the world is electric. That forces don't require contact. That solidity is just a delicate balance of attraction and repulsion, held in perfect tension. And then comes the most remarkable realization of all. Humans figured this out. We uncovered these hidden forces. We learned how to guide them. We built an entire civilization on top of them. That achievement stands among the greatest triumphs of human intelligence. So the next time you flip a switch, remember, you're not simply turning on a light. You're manipulating fundamental forces of nature. You're causing electrons to push and respond across entire cities. You're converting motion into electromagnetic fields and back into motion again. You're exercising real power over the fabric of reality. That is what electricity truly is. Not a convenience, not a utility, but a window into the deepest structure of the universe, and proof that humans can understand it and bend it to their will. That's the real story of electricity. Not comfort, not familiarity. Truth.